So my presentation is something that actually came out from Maximilian's project. I'm going to be talking about a Jaguar Identification Project that came to us, to the same group where Maximilian is developing his project, where I'm also doing my PhD, because this project has been interesting to a lot of people who are into conservation. And this follow-up thing about monitoring jaguars was something that a professor at Stanford was interested on, and then he reached out to us. So let me tell you a bit about myself. I am a computer scientist. I'm currently an AI engineer and DevRel at Vauxhall 51. And as I mentioned, I'm also doing my PhD at the Hasso Plattner Institute. I'm also an instructor at the Deep Learning Institute of NVIDIA and the Data Science Retreat. So most of these places have a collaboration here. And this is the team that has been working on this project. Professor De Melo is the head of the chair at HPI. Davide and Shahab are students at the Data Science Retreat. Alexandra is my colleague, and Abigail Martin is a person who leads the project in Brazil, this Jaguar Identification Project. So today we're going to be talking about the project. I'm going to give you an overview about what this project is doing. It's not only us. This is something that Abby has been working on for years. This is her passion project. And I'm going to tell you how we are curating the dataset that we are using for doing Jaguar identification using image embeddings, and how we did this with FiftyOne. FiftyOne has been an amazing tool for us to prepare the dataset. We had many of the issues that Maximilian discussed on his project. We also had class imbalance. We have a lot of near duplicates, and we use the embeddings framework that we have in FiftyOne and all the integrations with these different things to actually curate the dataset. And we have some interesting results that I can present to you today, but they are all basically preliminary. Like, this is something that at some point we're going to write a paper about, but these days I don't have that much faith on me or uh, anybody that I know writing a state-of-the-art model. What we really care about in this project is the quality of the dataset curation. This is something that Avi stressed a lot since we started the project, and it fit perfectly with what I'm doing at FiftyOne. So this was a natural fit. FiftyOne is going to be sponsoring, Vauxhall 51 is going to be sponsoring a Kaggle competition where we're going to be working with this particular dataset. And I'm going to be using this for my workshops. So if you're interested in what I'm presenting today, please join our Discord and check out the workshops that I'll be doing in relation to this. I'll be showing you how to build the identification models, how to prepare a submission for the Kaggle competition, what things we believe are good, what things we believe are not so good. And I'm going to give you today my opinionated idea about how to best approach this upcoming competition. So the Jaguar Identification Project is Abby's project. She started this and is dedicated to the long-term study and conservation of jaguars in the Pantanal of Brazil. This is a national park that is huge. It has like 1,200 wildlife species. And this is something that felt close to my heart. I'm from Venezuela, and we also have jaguars. They're also endangered in Venezuela. We call them tigres there. So this is something that I found interesting ever since I heard about the project. And this is both about conservation and education. Like, I asked Abby for permission to use this data set to teach my workshops, and I'm very happy with how interesting it has been so far to work with it. I don't know if you can hear the Krankenwagen. There was some very loud ambulance in my street. Sorry about that. I'm gonna be explaining to you the re-identification methods that we're using for the project. And if you want to check out the data collection project, the citizen science project, you can check out the link that is on the slides. We're gonna share this after the event. And you're also going to get a starter notebook that helps you curate the dataset using FiftyOne. That's also included in the things that we're going to give you at the end of the workshop. So this area, the Pantanal, has been affected by deforestation and wildfires recently, and this has affected the population of jaguars. So we're using this to see how the population is evolving over time. Jaguars seem to be doing very well in this area, but they're still endangered. This data set that we're going to be working on only has 40 different individuals. And people are investing a lot of effort into preserving these different individuals and tracking how they're reproducing, who is mating with whom, which behavior these jaguars have. And this is something that has been tracked in a very extensive manner for the last, I think, 10 years already. Abby has been publishing these Jaguar field guides that are very extensive, and we have used them as data for the project. So, as I mentioned, this is a huge national park. There's a very cool article that showcases what the project is about that was in the New York Times. It's also on the slides. You can get this later. You can Google "In the Land of the Jaguars" and you'll see a whole description about what we're doing. So the project is basically depending on ecotourism. It's depending on people taking photos of the jaguars in order to identify them. We want to have good demographic tracking of these individuals. So as I mentioned, Abby is curating these Jaguar field guides that have very detailed descriptions of the genealogy of the jaguars when they were observed and also descriptions of their different patterns. The patterns on a jaguar are like a fingerprint and they look different on the left side than on the right side. This is something that we can leverage for our re-identification methods. This dataset that we're using has very high quality images. Most of them are professional grade. And this also has some challenges because these are very high resolution images and we want to keep them as high resolution. We're also interested in using camera trap images, but then this presents an interesting computer vision challenge. It's going to be a domain adaptation challenge because the camera trap images have much lower quality. And this is something that has been recently added to the project. They started doing tracking of the jaguars with camera traps, and this is something that we're going to include also in our dataset. So here you see the inspection of one of the images. You can see that this is like very high resolution, and we can inspect the patterns of the jaguars with a lot of detail. I didn't include this in this presentation, but I'm going to share with you some GradCam representations that showcase which areas of the pattern are going to be activated the highest when we identify a particular individual. So our challenge here was to digest the Jaguar field guide data. We received more than 80 gigabytes of data from Abby from these 40 different individuals. And as Maximilian mentioned, we had, well, as was the case with Maximilian's problem, we had also a lot of duplication. We have a lot of duplicate images, and this is something that we need to be very careful about. If we create classification models that do not deduplicate the data set properly, we're gonna get like fake confidence. We're gonna have classifiers that are going to report very high accuracy, but this is probably due to cheating because having leaky splits, because of having very close duplicates between the training set and the test set. So this is something that we have to be very careful about. And we use embeddings to curate the dataset. And I'm going to show you how we do this with FiftyOne. And well, FiftyOne has a huge amount of utilities to work with embeddings. And it's very good for removing duplicates. It's very good for adding tags, metadata, the different predictions that we get from different models, like all the different annotations that we might have on the dataset. These are things that we can collect very easily and very meticulously with FiftyOne. Like we can keep like the different predictions that we get from the different versions of the classifier model. We can compare this very qualitatively, and we can inspect the different views that we have of the data set in a way that it's very, very nice for computer vision research. So we also have an integration with Hugging Face. The dataset, FiftyOne has an integration with Hugging Face. The dataset that I told you about, this 80 gigabytes of raw data, you're gonna be able to find on Hugging Face. And you also find different variations of the dataset. You will find a crop variation and a segmented variation. I'm gonna explain to you why are we doing this? Why do we have different variations of the dataset? And how this is important for us to get a measure of the performance of these classifiers. That is something that we can actually rely on. As I told you, the patterns on the Jaguar are what the biologists look at, and we want this to also be what the computer vision models look at. We don't want them to focus on the vegetation on the background. We don't want them to create spurious correlations between the background on the image and having a high confidence for this particular Jaguar to be all salad. So the utilities that we have in FiftyOne for dataset curation related to embeddings have been super important for us. Like putting together the different segmentations, putting together the different embeddings, the embeddings of the segmentations, the embeddings of the crops, like all of these different things, and being able to compare them has been very valuable for us to benchmark the different models and to have a good intuitive understanding about what is happening with this data set when we train it with different variations of the models. So something that you see highlighted on this particular slide is the uniqueness of every individual image. The uniqueness is a metric that we compare based on the embeddings. It's basically how outlying is a particular embedding that we have. And this is something that we're using to deduplicate and also select samples. We also have this metric called representativeness. And combining these two, we can find outliers or elements that are outlier, but also very important because they represent centers of clusters in the data. So this has been very useful for the exploration of the dataset. You see here different selections with different combinations of uniqueness and representativeness. This is something that you can manipulate with sliders in FiftyOne, and you can get a cool connection between the embeddings and the particular data points and the particular uniqueness, the particular representativeness. So I'm going to give you a brief overview about what image embeddings are. For those of you who are new to the concept, I know that for many of you this is all news, but this is something that I also explain in the workshops that I lead with FiftyOne. So when we train a neural network, we make it embed inputs that are semantically and visually similar, close to each other. And these dense vector embeddings are basically produced by every neural network that we use these days. Convolutional networks produce them after we do convolutions, and then we flatten them. The vision transformer has embedding produced at the final as the final output. And this is something that we can use to characterize the different images as points in space. So an image is going to be put in a point in space or it's close to other images that are semantically similar and visually similar. So if you have like these two different images, the dense vector embeddings that we're going to be creating out of them are going to be close in terms of cosine similarity or Euclidean distance or any other metric that you can use to compare points in space. This is a distinction with a sparse vector embedding, which is what we usually do to encode the classes. Like, for example, if I had 10 different individuals and I want to represent that both of these jaguars are the same, even though they have images with a different background, I would encode both of them with the same label positioning. This is not a dense vector embedding. This is sparse. This is a sparse vector embedding. This is what we use to encode classes. So as I told you, we use these metrics, the Euclidean distance and the cosine similarity, to compare embeddings. We basically are turning an image into a point in space. And if the embedding is good, then things that are semantically and visually similar are going to be close to each other. The cosine similarity is the cosine of the angle between the two embeddings, and the Euclidean distance is just a straight line, the length of a straight line between the 2 points. So in our upcoming Kaggle competition, we're going to be giving you different versions of the dataset, and we want you to curate it. We want you to play with the dataset using FiftyOne or whatever tool you would like, but of course, we're going to give you all the tools to do this in FiftyOne, so that you avoid spurious correlations. I'm going to explain to you what spurious correlations are and what is this so bad for our Reidentification models. So suppose that we have all these images from the different jaguars. How can I be certain that I'm not making my prediction on whether this particular jaguar is medrosa based on the spot pattern on the face of the jaguar or on this particular background? How can I be certain that I am not getting to a high confidence prediction that this particular jaguar is medrosa simply because I captured 10 different images with medrosa in a similar background? There is like no good way to know. We can do class activation mapping, GradCamp to inspect the predictions afterwards, but it's simply better to just remove the background. So when we give you the images on the training set that we're gonna share for the Kaggle competition, you're gonna have to do the segmentation yourself. Why is it important for you to do the segmentation yourself? Because the segmentation models are also not perfect. And I'm gonna be trying to curate my test set with as much quality as possible in the segmentation, but notice that I still have some vegetation here. I still have a little bit of a segmentation pattern that is keeping a little bit of the vegetation here. How can I be sure that this is not something that is gonna appear in the other images of this Jaguar that I'm putting? So I'm gonna be creating a test set that has different versions of the segmented Jaguars with data augmentation and some tricks that I'm gonna keep by myself so that you don't cheat. But this is going to be something that you're going to have to segment yourself. We're going to give you the raw images, also the images that have the bounding box for the Jaguar, but the test set is going to be mostly segmented images. I'm going to be curating different versions of the segmentations, and let's see how you do on this. Let's see how good can be your classifiers after you have curated a data set in the best way that you can come up with. So there are many tools in FiftyOne that will help you with this. Ultralytics has a very nice integration with YOLO-E. And this is literally these 4 lines of code. You can just copy paste these 4 lines of code, put it into FiftyOne, and you will get these segmentations. You'll get both the bounding box and the segmentation for this particular Jaguar. And then you can use this as your input for your Reidentification model. This is something that I encourage you to try. I encourage you to try different segmentation algorithms to curate this dataset in a way that makes the classifier robust. And this is super important. So here you see that using this YOLO-E segmentation, I'm getting different qualities in the segmentation. Here I ask it to give me the head of the Jaguar and also the body of the Jaguar. And the quality in many of these is very good, but there are still some artifacts. You see that in this particular case, we're missing this portion of the Jaguar. In this particular case, we have this, which is not what I asked. I didn't ask for a paw of the Jaguar. I wanted to get the body of the Jaguar or its head. So there's going to be some effort that you're going to have to put into this. You're going to have to curate a good Jaguar segmentation model in order for you to create a good prediction that identifies this particular Jaguar. So the dataset also has the challenge of it being highly unbalanced. Most of the images correspond to Medrosa. This is a very social and popular Jaguar. She's in many of the pictures, whereas we have very little pictures of Borbonetinha or Rio or Hero. These are jaguars that are more rarely observed. So this is going to be part of the challenge. You're going to have to account for the fact that there's going to be a very different representation of the different individuals. I can tell you about the dataset preparation guide pipeline that we use. You see that we have this grounding dyno in which we crop the body, we also crop the face, then we do a segment anything model, and then we get this output. And you see that here we have the Jaguar with a little bit of some artifacts over here. You see that there is like a little bit of noise here. Is this good? Is this bad for the model? I don't know. This is up for us to explore. We also follow this particular framework to deduplicate the images. We crop the bodies of the animals, then we use DynoV2 to produce embeddings, and then we use the cosine similarity to cluster similar images, and then we got rid of the most similar images. This is something that you can do also with the leaky splits plugin from FiftyOne. This is also like 3 lines of code. It's something that is very useful for you when you create your validation set. I encourage you to try to think well about how should the validation set that you're going to use to select hyperparameters for your model should look like. And this is something that you will do with the leaky splits functionality of FiftyOne way like with way less effort than one would have expected to do this maybe 3 or 4 years ago when this tool was not available. So this is the duplication of the test train split that we did for the particular classifier that we built for this baseline that I'm going to present to you later. You're also going to have to repeat for your validation set. In Kaggle, you have a limited amount of submissions that you can do per day. You're probably going to be able to submit the prediction only 3 times per day. So it's going to be important for you to create a very good and deduplicated validation set. This is another tip that I can give you for improving your performance in the competition. So this was the class balance that we have for our baseline classifier after the duplication. You can see that we eliminated many images. We also have a big collection of Jaguars that we decided to label as unknown. As they were so rare in the dataset, we decided to label them as unknown Jaguar just to get a baseline for what would be the performance of a classifier when it has this unknown subject. This is not necessarily how it's going to be in the competition. I'm probably going to include all of the subjects and I'm going to scrape images from the internet or take them from somewhere where I have a good permissive kosher license so that I can put some unknown subjects here so that this is something that we can explore with uh, a bit more challenge. Like in this particular example, we put the subjects that have very little support as those belonging to the unknown class. And the Jaguar ID classifier was built based on a Dino V2 model with the bit backbone. that produces embeddings, as we mentioned before. And we just fine-tune some of the heads that we have later, at the later stages of the model. So you see here that we have this backbone model to create image embeddings. We also did some experiments fine-tuning the embeddings using the ArcFace Loss, which is a variant of softmax that calls the embeddings from the same subject to be better dispersed. You see that here in this ArcFace embedding, the different subjects seem to be very isolated from each other, whereas in this softmax output, you're getting more of an overlap between the different embeddings. The code that produces this is on the repository that I'm sharing with you at the end of the slides. You can use this as a baseline for you to participate in the Kaggle competition. So before doing fine tuning on the Dino V2 model, we had these embeddings that had a huge amount of overlap. After fine tuning, you see that the embeddings are more isolated. So we believe that this is promising. This is something that you should try when you go into the competition. I would recommend you to try it. There are other approaches. You can use techniques like the ones that Maximilian was mentioning. You can use a triplet loss to select which are individuals that would be negatives for a particular Jaguar. Like you would decide, okay, this is an anchor subject, this is a positive subject, and this is a negative subject. This is something that will require you to curate the data set a bit more, but you can also use the embeddings from the ArcFace model to produce that. That could be like a second step that you can do on the fine tuning of the embeddings. And we're going to discuss these things on the workshops as well. I told you that we're going to be using like this data set for workshops here at FiftyOne. So I'm going to be teaching you these tricks and how you do this pipeline step by step and how you make it more sophisticated, tricks that you can do with k-nearest neighbors. All of these things is going to be part of this events. We're going to be doing both the Kaggle competition and some series of live workshops where you're going to be able to ask your questions about your submissions, like how to improve them, how to make this more robust, how to make your models more robust. So we also tried doing focal loss. Focal loss is this variant of cross entropy loss that is very popular due to RetinaNet, and we got some nice results out of this. The thing is that we got something here that I found very interesting, and that is that when we do the benchmark of the model with the segmentation of the body of the Jaguars, the accuracy went down. And I think that this is good because I think that in many cases, the model is having this upside in accuracy, it's winning in accuracy simply because it's relying on the vegetation pattern. And it's difficult for us to distinguish which is the vegetation pattern that is creating a bump in accuracy here. So that's also something that we're going to be discussing a lot in the workshops. So for those of you who are new to the term spurious correlation, this is a spurious correlation, right? Two things that are supposedly predictive of one another, but they don't actually have anything to do. Like the number of people who drown by falling in pools has no causal relation with the number of films that Nicolas Cage appeared in. And the vegetation in which a jaguar is standing should also have no correlation with its class. So this is something that we're tackling in this challenge. We want you to curate the data set so that the model understands the identity of the jaguar, just like a biologist would understand the identity of a jaguar. The model should not rely on vegetation to get a higher accuracy. The model should rely on the spot pattern. The spot pattern is like a fingerprint for the jaguar. So we want you to curate the data set so that the model learns that. And how do you make the model learn that? By just giving it good data. So There is a Gradio app that you can try on Hugging Face so that you can get a sense of on how the baseline model works. You can check it out here. You can take the images from the Jaguar Field Guide or any other resource that you find, like the Hugging Face repository, to try this and see how good is the baseline model in producing these different classifications. Something that's going to be our next challenge is to include camera traps. I show you only the high quality images of the Jaguars that were taken by basically professional photographers. The next challenge is going to be making this work on very low quality images, on images that are captured automatically by a camera trap. And here we are going to face the domain adaptation challenge. These are going to be images that look different. They're going to have very different lighting. Sometimes they're going to be captured at night. And we still want to do the identification of the Jaguars here. So the resources are here. You can find the dataset on Hugging Face. There is a notebook to perform embeddings-based exploration and segmentation on FiftyOne. And there are starter notebooks for the dataset curation, for the classification, and DNOV2 fine-tuning on the repository that is shared on the slides. So we also invite you to join the FiftyOne Discord. As I mentioned, I'm going to be talking about this challenge in my workshops in the coming months. So please join the Practical Computer Vision Workshops channel so that we can discuss these things. And that's all that I have for you guys today.
All right, fantastic, Antonio. Thank you for the presentation. There's a couple of questions and some comments. Let me see if I can't consolidate a few of these into something legible. I think some of the commentary was about learning more about the Kaggle competition. So I would just say this: look for communications, landing pages, Discord channels, all kinds of content that you can get into in regards to the Kaggle competition in the coming days, weeks, and months, as Antonio has mentioned. So stay tuned. More will be announced and will become accessible. Let's jump into some technical questions. How are you able to stop double counting? How are you able to tag each one of them by extracting each unique feature and identify them every time?
That's a good question. I mentioned that we can use the embeddings to compute uniqueness scores. So you see this in the presentation. You see that, let me actually go back to the slide where we have uniqueness and representativeness. You see that based on the embeddings, these are the projections of the embeddings in 2D. And based on the embeddings, we can compute how unique are the images. How weird they are on the embedding space is how unique they are. And how close they are to the center of other embeddings is how representative they are. So that's the summary of these two metrics that are very useful to curate and deduplicate the dataset.
Okay, I'll consolidate a few questions around CNNs, which I think basically revolve around how are you using CNNs, which ones were you happy with, which ones were you not, what is your general position here on CNNs as it relates to this project?
We use many different models. I'm not religious on machine learning models. I believe that you can never tell which model is going to be best for your particular dataset until you try it. So we're using for the baseline Dino V2, fine-tuned with the ArcFace Loss that gave us good results. And we also did many experiments with MobileNet and very small networks. We started with very small networks. Actually, if you see my slide here, you will see that the embeddings were produced with MobileNet. And this is a very small network that is convolutional, and it produces good enough embeddings for us to start the curation.
Let's take one more here, and then we'll take a fun one at the end. Are those figures comparing ArcFace and softmax and clustering at all related to the curse of dimensionality concept, or is there no connection at all?
The curse of dimensionality concept is the idea that when you have embeddings that have many dimensions, when you have a representation that has many dimensions, it's more difficult to do something useful in a machine learning model. And you can forget about that when you create a well-trained classifier, because this dimensionality is way, way, way lower than the original dimensionality of the input data. The input data is a huge image that has millions of pixels, whereas this embedding is something that has 1,000 different values or 512 different values. This is a very compact representation that is very useful. So it's literally low dimensional data considering the problem that we're facing.